Alright guys, let's get to the point. I got these flat lithium ion cells from the inbuilt battery of an old laptop to make a small portable power bank. So I started adding them together by using a glue to connect them in series in a 3S 2P configuration. Then I soldered by using a small piece of nickel strips and insulated with white tape to avoid short circuits while connecting them in series. These 4 terminals will be connected to the BMS. Before that, I used a 4-pin connector. It is used to charge the cells individually with an external 3S power supply. And here is the BMS that I got from the other laptop battery, which actually works very well because most of the BMS doesn't work and drain the cells all the way down to 0 volts. So I already tested this BMS. It will protect the cells from overcharge and over discharge. It also balances the cells with a 10 mV difference. Then I used a 2576 IC buck converter. These circuits gets hot basically when we draw more than 2 amps. So I started removing the upper layer of this board by using a small piece of blade to mount it on the heatsink. And I also removed the positive terminal because it will get short if you connect directly on the heatsink. And after a few minutes of work, if you see closer, the whole body is negative. And here is the small piece of aluminum that I used as a heatsink, and I already made a hole for the preset. Just make sure whether the preset is not touching the heatsink. After adding a thermal paste and connecting both together, I used a dielectric insulation paper top on the cell so it won't transfer the heat to the cell when the circuit gets hot. And to make it more safer, I connected the thermistor beside the buck converter so the BMS will disconnect the power to the load if the heatsink gets too hot. Then I connected a small switch and a small voltmeter to measure the battery voltage. After soldering everything, I used these pieces of acrylic sheets which I was already made a few holes for input and output. I connected them all together using a super glue. It dried so quickly in just a few seconds. Then I used a normal glue at the bottom and installed these batteries inside so there will be no movement when we fix it. I glued everything where it belongs and connected a small DC socket with a 5R22 Schottky diode as an input to charge the battery. And for the output, I connected a USB socket with a small piece of PCB. Then I used some more glue at the top with a piece of acrylic so it won't come out when we use the USB cable. Before connecting the buck converter to the USB socket, I measured the output voltage. It have to be around 5 volts and that's the voltage to charge the battery. After soldering them together, I covered the top with one more piece of acrylic sheet by using the super glue and also for the switch so it doesn't get inside when we push it. Then I charged it for a few minutes to see how it works. I connected a USB cable to charge the mobile and it worked really nice. Then I connected a 10,000 mAh power bank. It may draw more than 3 amps and it only dropped around 300 millivolts. And I also connected this mini DIY rechargeable voltmeter which I was made in my previous video. It uses to measure the battery voltage individually and the cells were almost equally balanced. And for the 12 volt output, I used a turbo cooling fan from the computer which can draw more than 1 amp. If you guys wonder how I'm using this DC socket as an input and as well as the output, that's so simple. I just connected the switch in parallel to the Schottky diode, so it gets shorted when we turn on the switch. And I also connected the buck converter and the small voltmeter to the cathode of the diode, so it acts as an indicator while charging the battery. Thanks for watching and see you in the next video. Bye.